So let's go over the chapter 3 to 4 practice quiz. They start off kind of easy and then they get tricky. So these first ones, just good practice doing circles and stuff. So the first one says find the equation whose graph is a circle with radius h and 2 to -4. So you just have to remember the circle equation is x minus h squared plus y minus k squared equals the radius squared. This is h comma k. So it's just x minus 2 squared plus y minus negative, that's where you got to be careful, y plus 4 squared equals the radius squared, so the radius is 8, so I'll just say 64. If you put 8 squared, I'd mark it right, but yeah, might as well multiply it out. Okay, pretty good. Now, 2 is a completing the square problem. So I say find the center and radius of the following circle, so x squared minus 8x plus y squared plus 4y minus 3 equals 0. Minus 3 equals 0. So we have to complete the square for x and the y. So you always take half of the number, the x part, so half of 8 is 4, and it's minus, so I say x minus 4 squared. And remember, when you do that, you get x squared minus 2 times them all together, multiply together, which is minus 8x, that's why you take a half. But the problem is then we get plus this one squared, plus 16. Well, we don't have a 16 here. We're just trying to model those two, so we got to take away 16. Now this thing here is exactly the same as that there, right? That's the process. This thing here is exactly the same as that there. Do the same thing with the y, plus we have 4, so I'd say y plus 2 squared. That's going to give us the 4y, right? 2 times multiply together, but we have 4 too much, so we take away the 4, and then we already had a 3, so that's equal to 0. Now we just put all the numbers on the other side and leave these. So we have x minus 4 squared plus y plus 2 squared equals, let's see, 16 and 4 minus 4 is negative 20. So that's negative 23. Put the other side, it's 23. Okay, and now we're pretty much done. So the center of the circle is 4 comma negative 2. And, oh, it's like the opposite of the first one, right? And the radius is the square root of 23, because this is the radius squared, right? That's the radius squared. So the radius is squared, which is a horrible number, but who cares? Just write it as the square root of 23. Don't have to worry about it. All right, number 3. The intersection of the two lines. So, good skill to have. We have two lines I just made up, 3x plus 2 and 2x minus 1. 3x plus 2, y equals 2x minus 1. And all you do is you set those two things equal, solve for x, and then solve for y. Negative 2x minus 1. Okay, but to make sure I write 3x plus 2, negative 2x minus 1. Okay, set them equal. 3x plus 2 equals negative 2x minus 1. Let's put the x's over here. Negative 2 becomes positive 2, so it's 5x equals positive 2 becomes negative 2. We already have negative 1, so that's negative 3. So x is equal to negative 3/5. Y, we could use either one of these formulas now to find y. I like positive numbers, so this is negative. Yeah, whatever. I'll use the first one. So if this is x, then y is equal to 3 times x, 3 times negative 3/5 plus 2. 3 times negative 3 is negative 9. That's negative 9/5 plus, okay, I'm going to be really clever with fractions. 2 is the same thing as 10/5, right? 10 divided by 5 is 2. So 3 negative 9 divided by 5. I think I did that right. So negative 9/5 plus 10/5 looks like the 10 wins. So y is 1/5. So our intersection point then is negative 3/5 comma 1/5. And if you want to do decimals, you could say, what's that? Negative 0.6, 0.2. You know, that's fine too. So. Okay, set them to as equal, find x. When you find x, you can find y by using either one of those. They should give you the same thing. Make sure of that, try it out, see if they give the same thing. All right, number 5. This is just like practicing with lines. Wonder if I can fit it in here. So it says the average price of gas in 2005. They had ones like this in the chapter. It's a good problem. It was $2.75 a gallon, and in 2018 was $3.49 a gallon. I just made these up. It's kind of realistic. Using a linear model, what will the price per gallon be in 2025? So assuming this price goes up as a straight line, which of course it doesn't. It goes up, it comes down, it goes up a lot, comes down a lot, hopefully. Who knows? But let's assume it's a straight line. Okay, so 2005 was the first one. So that's 275. So we have some points here, right? So 1 point is 2005, 2.75. The next point was 2018, 349. 2018, 349. Draw a line here. So now we find the line, and then we plug in 2025. So we have 2 points. Let's find the slope. Let's do the big one minus that one. So the slope is 3.49 minus 2.75 divided by 2018 minus 2005. That is, better get a calculator here. 349, 3.49 minus 2.75 divided by, I'll just do it all divided by, what's that, 13? 13 equals, horrible thing, 0.056923. That ought to do it. That's a lot of decimal places. Let's see, it's going up, so I know it's positive. I didn't mess that up because I always mess that up, but its price is going up, so it's a positive slope. So that's how much it goes up per year. About 5.7 cents, right? That's like 5.7 cents because we're doing stuff in dollars here. So all right, that's about. Wait, no, is that right? 0.05. Yeah, about 5.7 cents. Okay, so then we use 1 point to find the line. Let's use the first one. Why not? So y minus y1, 2.75 equals the slope. I'm going to round that off to 0.057. I think that's good enough, right? 9, that's really close to make that a 7. So equals, why did I do that? Equals the slope, 0.057 times x minus the x point, 2005. Y is equal to 0.057x. 0.057 times 2005, so times 2005 is equal to 114.13. I'll keep it 0.13. Minus 114.13 plus this plus 2.75. So add those together. So plus 2.75 equals this. Okay, so I get y is equal to 0.057x minus, see, is this all right? Price is going up. Y minus y1 equals mx minus x1. Yeah, okay. Minus 116.88. Okay, so that is our model. Now let's plug in 2000. What do we want to know? We want to plug in what it is in 2025. So x is 2025. So in 2025, it's 0.057 times 2025 minus 116.88. And we know it better be bigger than 349 because the price is going up. So let's see what we get. 0.057 times 2025 plus, minus 0.057 times 2025 minus 116.88. And I did something wrong. What did I do wrong? Y minus y1 equals m x minus x1. Oh, wait. No? 0.052005 times 0.057. 114. Huh. Okay, let me try that again. 0.057 times 2005. 0.057 times 2025. 150. Okay. So something is that, did I do that wrong? You don't know if you guys should have correct me. 3.49 minus 2.75. 0.74 divided by 13.057. No, that's right. Okay, so the slope is right. So y minus y1 equals slope times x minus x1. So plus 275, put it over here. 0.057x, 0.057 times that is this, plus this. Oh gosh, it's plus that. I hate that, right? It's minus and plus, I added it together. Okay, whenever you get an S that doesn't make sense, that's what you do, right? What did I do wrong? What did I do wrong? How can this be that, make it negative? Okay, so it's 114.13 minus 2.75. Okay, this is 111. Jeez. 111.38, which you guys probably knew. Waiting for me to figure it out. Sorry about that. So minus 111.38. Okay, now it should make sense. Now I should get a number that makes sense. So 0.057 times 2025 equals that, minus 111.38. And now it's $4.045. So 4.045. So $4.045. That makes sense, right? Okay, so mistakes are easy to make like that. Check that, obviously, a negative and a positive. Yeah, sorry about that. Okay, good, but I think we got it figured out. Phew. All right, now the back side. There's only one problem left, but it's a hard problem. Number 6 here. Okay, I'm going to erase all this stuff here, because this number 6 is going to take the whole board, and maybe more. It's the fun one. So, let's do this. Okay. I'm going to use a fresh pen. This one's getting kind of warm here. All right, we're ready to go here. So, what do we got? Parker, standing at the origin, walks 12 feet per second towards Hawken, who's standing 30 feet east and 20 feet north. Okay, we got to draw these pictures right. It's so important to draw a picture right. So, standing at the origin. So, here's Parker, standing at the origin. And he walks towards Hawken, who's standing 30 feet east and 20 feet north. East is this way. So this is 30. Now I'm trying to do it to scale because it helps a lot. So 20 is maybe there. So he's right here. And I always put the x1 first. 30 comma 20. See, no, so that's right? 30 feet east, 20 feet north. East is okay, that's right. So he goes this way at 12 feet per second. 12 feet per second. Okay, picture drawn. That's going to be the most important part. Write parametric equations. Okay, for Parker. So we want to write his parametric equations here. So, let's see. We need to know how far he went in the x. Oh, how long it took him to get there. That's the first step. We know how far he went in the x direction. He went 30 feet. We know he went 20 feet in the y direction. But first, we got to figure out the time it took him to get there. So the distance, we can use the distance formula, right? The distance is the square root of the x distance. We want to find this distance. We know this is 30, that's 20. So it's just the Pythagorean theorem, 30 squared plus 20 squared. So we do that. And what do we get? 30 squared plus 20 squared. I get 36.0555. So 36.055 5. So the time it took him is always distance divided by velocity. So 36.0555 divided by 12. And that would be 3, boy, practically exactly 3. Can I just say 3? I'm just going to say 3. 3 seconds. Took him 3 seconds to get there. All right, well, that's cool. Now, we know how fast he was going in the x direction and how fast he was going up, right? If he was walking this way, which means he was going this way, and he was also going that way, which put him there. So his Vx is the distance in the x direction he went, 30 divided by 3 seconds. I'll write the formula. It's always good to write distance divided by time, even though it's sometimes you know how to do it, but it's always good to write that because people do it backwards, get upside down. Always helps write the formula. Distance divided by time. The x distance, so 30, I could put x divided by time too. 30 divided by 3, that's easy math, so 10 feet per second. And his Vy, he went 20 in that direction. Okay, I have the formula right there, I'll need to write it again. 20 divided by 3, let's see, a 6 with 2/3, 6.66. Let's say 6.67 feet per second, a little bit slower, which makes sense. Okay, did I do that right? 20 divided by 3, 6, 8, 2/3. Yeah, I think that's right. Okay, so now we can write his parametric equations. It's always, the way parametric equations means you want his x position as a function of time, which is always the x starting point, plus his x velocity times time, which the starting point in the x direction was 0. Right, the starting point was 0, 0. Oh, in the y direction too. We started at 0.00. So this is 0, so it's just Vx times t, which is 10t. And in the y direction, this is y starting point, which was also 0, plus his y velocity times t. So y is equal to 6.67t. Okay, that's what we got there. Easy because he started at the origin, so we don't have the pluses. All right, that was part A. Part B, how long does it take Parker to reach Hawken? Oh, by the way, I will switch this around on the regular quiz because we already figured that out, right? That's the first step, is you figure out how long it takes. So I just messed that up there. Really, you got to figure out B first. So B, how long it takes, we figured out right here, which is 3 seconds. So we already did that. So B, 3 seconds. Yeah, that's weird. Why did I do that? Because we have to find that for the parametric equations. Okay. Oh well. Okay, then part C is the hard part. Part C says, Ava is standing 15 feet east of Parker. What's the closest Parker gets to Ava? So 15 feet, halfway there, right? So right there is Ava. So to find closest, you draw a perpendicular line. Right, that's the closest. So when Parker's walking along here, the shortest distance is going to be the perpendicular line to Ava. So Ava is at x equals 15, 0. So we got to find now that point, this point where they hit. Okay, because then if we know that point, we can find that distance. We want to find that distance d there, how far apart they are when they're closest. So we got to find that point. Then we can use the distance formula because we know this point. If we know this point, we can find the distance because we can always find the distance between 2 points. All right. So let's do that. So we have a perpendicular line. Now we know the slope of the black line. That's pretty easy. The slope of the black line, m, is y over x, so it's 20 over 30. So it's 20 over 30, which of course is 2/3. So the slope of the blue line, m, is -3/2. That's even prettier, right? That's -1.5. Okay, now we know the slope of the blue line, and we know a point. We have a point 15, 0, where Ava is standing. Now we can figure out the equation of the line for the blue line. So y is equal to, we don't know b, so we'd have to use a y minus y1 thing. Y minus 0 y minus y1 to 0 equals negative 1.5 x minus 15. Y minus y1, 0 equals m, negative 1.5 x minus x1. Okay, did that right. Or y is equal to negative 1.5x. Oh, what's that? 1.5 times 15. 1 of 15 is 15. Half of that is 15 is 7.5. So 22.5 plus 22.5. See, half of 15 is 7.5 plus 15. Yeah, I think I did that right. Okay, so that is the blue line. Now to find that point, that's where the blue line and the black line intersect. So we need to find an equation for the black line, but that's easy because it goes to the origin. So the black line is just y is equal to, since it goes to the origin, it's just the slope times x. So we said the slope is 2/3, so y equals 2/3 x. That's Parker's line. Now, when do those two lines hit? Okay, so we set those two things equal. So we set 2/3 x equal to this, equal to negative 1.5x plus 22.5, and we solve this for x. We have a 2/3 mixing with the negative 1.5, that's just ugly. Oh well. So we have 2/3 x, let's change that to points, how many sixes we want to keep? 0.667, let's say, right? Yeah. Plus 1.5x is equal to 22.5. Add that together, let's see, that would be 2. Let's see, I better do it on a calculator. My head's not working very well right now. 0.667 plus 1.5, 2.167. I could guess that. 2.167x equals 22.5. Divide both sides by 2.17. X is equal to x is equal to 10.383. Let's say 10.38. So 10.38. So the x value here, this x value here is 10.38, which, yeah, that's probably about right. Because it's about 15, looks right. So the y value then, so there's our x value. So the y value then is, always use the easy formula, right? Let's use this one, is 2/3 of the x value. So what's 2/3 of 10.38? So I'll divide that by, multiply by 2, divide by 3. I get 6.92. So that's 6.92. Okay. I don't know who's calling me, but I'm going to ignore it right now. All right, so if that, now we know the point. Now we got to find the distance between 15, 0 and that point. That's the last step. How far are they? Distance between that point. So I am going to do that. Where can I do that? I'll do that up here. So we have 2 points. We have Ava's at 15, 0, and they're closest when Parker's at 10.38, comma 6.92. So what is the distance between those 2 points? So the distance is the square root, and we just subtract them. This one minus that one, 15 minus 10.38 squared, plus 0 minus that, negative 6.92 squared. I didn't have to put the negative right because we're squaring it, but whatever, I'm just doing that. And now we make sure we can use our calculators. See if I can do this in one fell swoop. 15 minus 10.38 x squared plus 6.92 x squared equals that, square root. And I gotta try that again. 15 minus 10.38 equals this. That's what I did wrong. Plus 6.92 equals that, square root. I get 8.32, which is, and that would be feet because we're dealing in feet. So finally 8.32 feet. That's how close they get. Which, yeah, looks about right. Sure, I'll take that. Okay, that was the hard part, finding out the distance there. Okay, hope this makes sense. Again, part B should have been part A. I'll mix that around the regular quiz because that's kind of confusing. So why did I ask that? But okay, good. Thanks for listening. That's a long video. Good luck on these. Goodbye.